Your dad probably remembers these, the car that could drive into a lake and keep going, the Amphicar. It sounded like the future in 1961, a car that was also a boat. What could go wrong? Well, quite a lot, actually. The idea wasn't new. Military vehicles had been doing the water thing since World War II, the DUKW, the Schwimmwagen, various amphibious tanks. They worked, mostly, in the sense that they got soldiers across rivers without everyone drowning. The bar was low, but a civilian amphibious car? For regular people? That was different. That required something that actually worked well on both land and water. Something comfortable. Something safe. Something you could sell to a suburban family in Connecticut. In 1959, a German engineer named Hans Trippel thought he had the answer. Trippel wasn't some amateur dreaming in his garage. The man had been building amphibious vehicles since the 1930s. He'd designed the Schwimmwagen for the German military during the war. He knew water. He knew cars. He figured he knew how to combine them. The company was called Quant Group. Yes, that Quant Group. The same family that would later become the largest shareholders of BMW. They had money, they had ambition, they had Hans Trippel. What they didn't have was a clear understanding of physics. See, here's the fundamental problem with amphibious cars. And it's a problem that has never been solved. Not in 1961, not today. The requirements for a good car and the requirements for a good boat are essentially opposite. A car needs to be heavy and low. Weight gives you traction. A low center of gravity keeps you stable in corners. You want stiff suspension. You want direct steering. You want the wheels firmly planted on the road. A boat needs to be light and buoyant. You want it to float high. You want a hull shape that moves efficiently through water. You want sealed compartments. You want propellers positioned correctly relative to the waterline. The Amphicar tried to be both. It succeeded at being neither. Let's start with the land performance. The engine was a British Triumph Herald 4-cylinder, 43 horsepower. That's it, 43. A 1961 Volkswagen Beetle made 40 horsepower. So the Amphicar had 3 more horsepower than a Beetle, while weighing almost 2,300 pounds. For reference, that same Beetle weighed about 1,600 pounds. The Amphicar was carrying an extra 700 pounds of boat, sealed doors, double hull, bilge pumps, propellers, all the stuff you need to not sink. And all of that weight was being pushed around by an engine that belonged in a car half its size. 0 to 60? Don't ask. Actually, I'll tell you, about 43 seconds. That's not a typo. 43 seconds to reach 60 miles per hour. If you could even get there. Top speed was around 70 miles per hour, downhill, with a tailwind and optimism. The handling was exactly what you'd expect from a car designed to float. Soft, vague, disconnected. The suspension had to be compliant enough to handle launching into water without destroying itself. That meant it wallowed on the road like a waterbed on wheels. The steering was imprecise because the front wheels were inside a sealed hull. The brakes were adequate. Barely. Drum brakes all around, which was normal for the era, but the weight made stopping distances longer than comparable cars. So on land you had a slow, heavy, wallowing vehicle that cost more than a Corvette. In 1962, an Amphicar cost around $3,200. A base Corvette was about $4,000. For an extra $800, you could have a sports car with 300 horsepower instead of a boat car with 43. But surely it was worth it for the water performance, right? The thing is, it wasn't great there either. In the water, the Amphicar could reach about 7 miles per hour. For comparison, a decent kayaker can paddle at 5 miles per hour. An Olympic kayaker can hit 12. So the Amphicar, with its 43 horsepower engine, could barely outrun an average person with a paddle. The propulsion came from 2 propellers at the rear, small ones. They were driven by the same transmission that powered the wheels through a transfer case. You had a lever in the cabin that engaged the propellers. Another lever controlled the front wheels, which acted as rudders in the water. Yes, you steered with the front wheels, Not a proper rudder. The wheels. They just turned in the water and redirected the flow. It worked. Slowly. Turning radius in water was about as tight as a cruise ship. The freeboard, that's the distance from the waterline to the top of the hull, was around 12 inches. Anything more than light chop and you were taking water. The doors had double seals, but they weren't submarine doors. They were car doors with extra rubber around them. If you've enjoyed this so far, hit subscribe. We cover engineering stories like this every week. All right, back to the boat car. Here's where the real problems started. Water and cars don't mix. Everyone knows this. Hans Trippel knew this. But the Amphicar's design created problems that couldn't be solved with just better engineering. They were baked into the concept. The engine sat in the rear, partially exposed to water spray. The Triumph engine wasn't designed for marine use. It had no protection against water intrusion. The electrical system was standard automotive, which meant it corroded constantly. Salt water was essentially a death sentence for the wiring harness. The bilge pumps were electric. When the electrical system failed, the bilge pumps failed. When the bilge pumps failed, the car filled with water. When the car filled with water, it sank. And they did sink. Multiple Amphicars went to the bottom of lakes and rivers. There's no official count, but documented cases include several drownings and numerous close calls. The Coast Guard eventually required Amphicars to carry proper marine safety equipment, life jackets, flares, the works. The door seals degraded over time. Rubber does that, especially rubber exposed to both road grime and water. A seal that worked fine in 1963 might leak badly by 1965, and you wouldn't know until you were already in the water. The propeller shafts ran through sealed bearings at the transom. These seals also degraded. Water would seep in along the shaft slowly at first, then faster. Owners reported constant vigilance about water in the bilge. Some installed larger aftermarket pumps, others just carried buckets. The transmission was a peculiar arrangement, 4 forward speeds plus the water mode. The gear selection wasn't intuitive. There are stories of owners accidentally engaging the propellers while on land, which did interesting things to anything behind the car. There are other stories of owners forgetting to engage the propellers when entering water, which resulted in a car floating helplessly until someone figured out what was wrong. The fuel system was another compromise. The tank had to be sealed differently than a normal car because it might be partially submerged. Venting was complicated. Some owners reported vapor lock issues, where the fuel would partially vaporize in the lines and starve the engine. Imagine that happening in the middle of a lake. The cooling system was actually clever. When in water, the engine was cooled partially by the surrounding water. A heat exchanger transferred heat from the coolant to the lake or river. This worked well in theory. In practice, the intake for this system could get clogged with weeds, debris, or silt. Overheating in water was possible if you stayed in too long or ran the engine too hard. Now let's talk about the manufacturing. The Amphicar was built in Lübeck, Germany. Production quality was inconsistent at best. The seam welding on the hull was critical. Every weld had to be watertight. In a factory setting, maintaining that standard across thousands of units was difficult. Some Amphicars came from the factory with leaks. Others developed them quickly as welds cracked under the stress of road vibration. The steel body had to resist corrosion from both road salt and water. It didn't, particularly. Rust was endemic. Amphicars rusted from the inside out as water collected in the double hull and couldn't drain properly. They rusted from the outside in, like any car of the era. They rusted at the seams where dissimilar metals met and created galvanic reactions. Between 1961 and 1968, about 3,900 Amphicars were built. That's total global production, less than 4,000 units over 7 years. Of those, about 3,500 came to the United States, which was the primary market. Why America? Because Americans had money, lakes, and enthusiasm for novelty. Also because European regulations were tighter. In Germany, an Amphicar was registered as both a car and a boat, requiring 2 sets of inspections, 2 sets of insurance, 2 sets of fees. In America, the regulatory framework was more accommodating. For a while. The price point was the killer. $3,200 in 1962 translates to roughly $30,000 today. For that money, you could buy a capable car and a small boat, separately. Each would do its job better than the Amphicar did either job. The market for people who specifically needed one vehicle that could do both was small. Mostly it consisted of wealthy novelty seekers. Lyndon Johnson famously owned an Amphicar. He would terrify guests at his Texas ranch by driving them toward the lake while shouting that the brakes had failed, then splash into the water as they screamed. Good times. But Johnson was rich and had mechanics on staff. Regular owners faced the reality of keeping an Amphicar running, which was expensive, time-consuming, and frequently frustrating. Parts were difficult to source. The Triumph engine components were available, but the custom amphibious hardware was not. When a seal failed or a propeller shaft bearing wore out, you were hunting for specialty parts from a small German manufacturer that didn't have a robust dealer network. Maintenance was complicated. After every water use, you were supposed to flush the lower components with fresh water, grease the propeller seals, check the bilge, inspect the door seals. Most owners didn't. Most owners treated it like a car, drove it into water occasionally, and wondered why things broke. By 1965, it was clear the Amphicar wasn't going to be a commercial success. Sales had peaked in '63 at around 800 units and were declining. The Quant Group was losing money on every unit. The factory couldn't achieve the economies of scale that would make the price competitive. 1968 was the final year. Production stopped. The remaining inventory was sold off. The tooling was presumably scrapped or mothballed. Hans Trippel moved on to other projects. The dream of the civilian amphibious car was dead. Was it the concept that failed, or the execution? Both, honestly, but mostly the concept. The fundamental physics haven't changed. A vehicle that's good on land will be bad in water. A vehicle that's good in water will be bad on land. You can push the compromise around, make it less terrible at one thing by making it more terrible at the other, but you can't escape the trade-off. Modern amphibious vehicles exist. The Watercar Company makes them. So does Gibbs Sports. These are better than the Amphicar in every measurable way. More power, better sealing, proper marine engineering. The Watercar Panther can hit 80 miles per hour on land and 45 miles per hour on water. That's actual performance, not just survival. But they cost upward of $130,000. For that money, you could buy a very nice car and a very nice boat. The economics still don't work for mass adoption. The military continues to use amphibious vehicles because the military doesn't care about economics. When you need to land troops on a beach, you build whatever accomplishes the mission. Cost per unit is secondary to capability. The Marine Corps' amphibious combat vehicle costs millions each. It works. It's not efficient or elegant, but it gets Marines from ship to shore. Civilian amphibious cars remain a novelty, a toy for enthusiasts with money and patience, not a practical transportation solution. The Amphicar itself has become a collector's item. Surviving examples in good condition sell for $50,000 to $90,000, which is ironic. A car that was too expensive when new has become even more expensive as a classic. Restoration costs are high because the specialized parts have to be fabricated. The pool of experts who understand these vehicles is small and shrinking. There are Amphicar clubs, annual gatherings where owners drive their cars into lakes together, probably while holding their breath a little. The most famous is the Lake Celeste event in California, where dozens of Amphicars take to the water. It looks charming in photographs. What the photographs don't show is the trailer full of spare parts, the dewatering equipment on standby, and the genuine anxiety of owners wondering if this will be the day the old seals finally give out. The legacy of the Amphicar is a cautionary tale about niche engineering. Some problems don't have good solutions. Some compromises produce a product that satisfies no one. Some markets don't actually exist, no matter how cool the idea sounds. Hans Trippel spent most of his career chasing the amphibious dream. Before the Amphicar, he built prototypes for military and civilian use. After the Amphicar, he continued designing variants that never reached production. He died in 2001, still believing that the amphibious car could work if only the execution was right. Maybe he was right. Maybe someday materials science and propulsion technology will advance to the point where a true dual-purpose vehicle is practical. Electric motors could solve some problems. They're inherently sealed and don't need air for combustion. Advanced composites could reduce weight while maintaining strength. Active suspension could adapt between road and water modes, but probably not. The fundamental tension between flotation and traction, between weight and buoyancy, between hydrodynamic and aerodynamic efficiency, these aren't engineering problems waiting for better solutions. They're physics problems that define hard limits. The Amphicar exists as a monument to human optimism, the belief that any problem can be solved with enough cleverness. Sometimes that's true. The Amphicar proves that sometimes it isn't. If you own one today, you own a piece of that optimism, a strange, leaky, underpowered, impractical piece of history, a car that promised you could drive anywhere, including into the water, and technically it could, for a while, until it couldn't. The last Amphicar rolled off the line in 1968. 57 years ago. The company is long gone. The factory is long gone. Hans Trippel is long gone. But somewhere out there, somebody is loading an Amphicar onto a trailer, driving it to a lake, backing down a boat ramp, and hoping this time the seals hold, because the idea is just too compelling to give up on. A car that becomes a boat. Magic, if you don't think too hard about the engineering. And that's the Amphicar. 43 horsepower of ambition, 2,300 pounds of compromise, 7 miles per hour of water capability, less than 4,000 built, and a surprising number still running, against all odds. If your family had one of these or you've seen one in person, drop it in the comments. And if you made it this far, subscribe. We cover engineering stories like this every week, the successes, the failures, and the ones that were both at the same time.